Okay, today we're working in section 2.4, converting units of measurement across measurement systems out of Al Grosch's book, Developmental Math 2. Um, we're going to talk about converting between the U.S. system, which is the system most people in the United States are familiar with. This is the one that we learned when we were growing up, feet, yards, miles, and so on. And we're going to convert to the metric system, which is sometimes scary for people. I don't know. It might be scary for you or not. I don't know. But don't avoid it. If it is scary, don't avoid it. Just trying to get my settings here. All right. The first thing I want to say to you is it's not really beneficial to try and memorize this chart. There's a lot of stuff here. And you have this information at your fingertips on the internet, on an app on your phone, whatever it is. For this class, you will be required to do some of these conversions, but the conversion units, or this information here, will be given to you in the question when you're required to do the conversion. So really what you need to know is how to use it. Okay, so that's what we're going to work on today. We're going to work on converting back and forth between US and metric systems. Steps to convert units of measurements across measurement systems. Number one, develop a plan for going from the current measurement unit to the desired measurement unit, and we're going to use multiplication and or division for that. Carry out your plan, making sure you end up with the proper units, and that's the key there. It's all about converting between the units. So this example says if a woman is 170 centimeters tall, how many inches tall is she round to 2 decimals? And we'll talk about the rounding when we've done the actual conversion. So we're talking about converting centimeters to inches. We're going to develop a plan, and here's the conversion rate. You can see this on the chart on the previous page also. 2.54 centimeters is equal to 1 inch. So to carry out a conversion like this, we're going to do what we call dimensional analysis, or multiplication of the unit multipliers. So this is what we do. We start with the given information, 170 centimeters. And make sure that when you write it out, you use the units and you put it over 1. And then you're going to multiply that times a conversion. But this is the key. Where you put the units is actually important. You always starting, this is the information you're given. You always put it on the top. It's always over 1 as a fraction. Now, to get rid of centimeters, we have to have centimeters diagonal. So it's just like cross-canceling with a fraction. So we need to put centimeters down here. So we're going to put centimeters here. And we're converting 2 inches, so we'll put inches on the top there. And this is really important, that you have to put the units in first. And the centimeters need to be diagonal so that they cross-cancel, and you'll be left with inches. Now, we have to have some numbers here. And these numbers come from the conversion unit that you're given. 2.54 centimeters equals 1 inch. So 2.54 centimeters equals 1 inch. And we have a multiplication here. We cross-cancel these centimeters just like that. And then we multiply the top times the top, the bottom times the bottom. And that gives us 170. Well, I can't really write here. 170 times 1, which is 170, over 1 times 2.54. So the ones don't really mean anything. So we end up with 170 divided by 2.54, which is, you can see that right here where the author worked it out for you. You could do the long division on this. You could put it into your calculator to check it, but it comes out to be 66.93. And of course, we need to look at the units. Since the centimeters were diagonal, they canceled, and the units left were inches. So this is in inches now, 66.93 inches, and that's the rounded decimal there. All right, step 2. Carry out your plan. Oh, well, here it is. where's the second example? If a man weighs 150 pounds, how much does he weigh in kilograms? And again, we're going to start with this given information, 150 pounds. I'm going to get some room right here. 150 pounds over 1. I need the pounds to cancel, so I'll put pounds down here on the bottom. I want to convert to kilograms, so I'll put kilograms here. The information or the unit multiplier is here. 1 kilogram equals 2.205 pounds. So we need to put that in here. 1 kilogram is 2.205 pounds. And you can see now this pounds cancels with this pounds, and we're left with the unit of kilograms. So again, 150 times 1 is 150 over 1 times 2.205, and the units are pounds. Again, a division here. So you could do the long division on this. I don't really have room on this page to review the long division with you. But the author is telling you here, once you do that division, it comes out to be 68.027 kilograms. So that's the basics of converting between English or U.S. units and metric units. Okay, let's see. A barrel. If a barrel contains 10 gallons of water, how many liters are in the barrel? Round to 1 decimal. So step 1, we have our conversion. 3.79 liters equals 1 gallon, or also 1 liter equals 0.26 gallons. Now, they look like two different unit conversions, two different conversion amounts, but really they will both work to give you the same answer. One will involve multiply, depending on how you set it up, and the other will involve divide. So if we look down the page here, what did we start with? We started with 10 gallons. So we can write 10 gallons over 1. We want to get rid of gallons. We want to be left with liters. All right, the conversion says 1 gallon equals 3.79 liters. And this way, that when you set this up, of course, the gallons will cancel. This is going to be multiplied. 10 times 3.79, because the two numbers are both on the top, 1 times 1 on the bottom. And that ends up being 37.9 liters. But if you set it up a different way, let's go over here and set it up a different way. We're still started with 10 gallons. We're still going to put gallons on the bottom and liters on the top, but this time we're going to use this conversion, where 1 liter equals 0.26 gallons. And of course, you can cancel gallons, but this time now when you multiply across the top and the bottom, you're left with 10 times 1, or 10, over 1 times 0.26. And this one involves division. But when you do that division, you still end up with 38.5 liters. So either way, they both come out to be the same. Now, they don't look the same. Why? Because the conversion, since one says 37.9 liters, the other one says 38.5 liters, which really don't look the same. But you have to remember that these conversions here, both of them, this one and this one, are both approximations. And whenever we do use rounding and approximations, it causes us to have answers that are slightly different. However, in your homework, whatever homework system you're using, either one of these answers would be accepted as correct. It's your work up here that you need to be careful with. Of course, this one over here on the left was easier because 10 times 3.79 is a lot easier. In fact, you can do this mentally than 10 divided by 0.26, which is going to involve a lot of long division and decimal and stuff there. So I wouldn't recommend doing it this way, although it's acceptable. This way is easier because you can do the multiplication a lot faster than you can do the mental division. Okay. If a temperature outside is 90 degrees Fahrenheit, what is the temperature in Celsius? All right, when you're dealing with temperature between Fahrenheit and Celsius, it is not a straight conversion. They are not proportional. So you can't use the same method to convert. Instead, you're going to use a method of a formula. And if you flip back a couple pages, on page 58, the formula to convert between Celsius and Fahrenheit are both there. All right. So if the temperature outside is 90 degrees Fahrenheit, what is the temperature in Celsius? So we're looking for Celsius. So we want to use the formula that says Celsius equals, and again, this is on the bottom of page 58, 5/9 times Fahrenheit minus 32. And of course, those parentheses are really important because you're going to need to do this subtraction first before you multiply times a fraction. So the Fahrenheit temperature was 90, so we're going to substitute the 90 right in there, and you can see it here. It's right here. When you substitute the 90 in there, 90 minus 32 is going to give you 5/9 times 58. And of course, you can do 58 times 5/9 by doing 58 times 5 divided by 9, and all of that, once you do the math and you simplify it out, becomes 32.22. All right, we got some practices here. If someone kicked a ball 12 meters, how many feet did the ball go? So using what we know about the unit multipliers, we're going to start by setting this up. I'm starting with 12 meters, so I'm putting that over 1. I need to get rid of meters, so I'll put meters on the bottom here. I want to stay with feet because that's what the question asks me to convert to. Okay, when you flip back to page 58 where you have all your conversions, there's two conversions for feet and meters. One says 0.305 meters equals 1 foot, so we can try that. 0.305 meters equals 1/4. And again, you can find those on page 58 of your book. Okay. The other one says, if we start with 12 meters, we want to convert meters to feet. The other conversion says 3.281 feet. Oops, not 2. 3.281 feet equals 1 meter. And you can have a choice. Whichever conversion you want to use, meters are going to cancel and you'll be left with feet, but one of them is going to give you multiply. The other one is going to be divide. If you carry this one further out like this, 12 times 1 gives you 12 over 1 times 0.305 is 0.305. And this is a division here, which is more difficult than if you look down here at the second one, 12 times 3.281 over 1 times 1 is 1. So this one is all multiply, which is so much easier, especially since we're not using a calculator on these. You can write this out. You can multiply it down. It comes out to be 39.372. And of course the units, because the meters canceled, the units are feet. So there we have it. Now, if you do the division on this the first part up here, you might not get exactly 39.372. In fact, you probably won't. But that's because these conversions are estimations. So it's okay if they're a little bit off. It's always an estimation anyway. All right, let's look at number 2. If Jim drank 2 quarts of water, how many liters do you drink? Okay, we're converting quarts to liters. So we're going to start with 2 quarts over 1. We need to get rid of quarts. We want to stay with liters. Do we have 2 conversions? If you look back on page 58, there are 2 conversions. I'm going to use the one that has a 1 down here because it's going to make the figuring easier. So I want to know 1 quart equals what? 1 quart equals 0.946 liters. So multiply across the top after you cancel these quarts. You have 2 times 0.946 over 1, and the units left are liters. So you just have multiplication across the top. When you do 2 times 0.946, you get 1.892 liters. All right, number 3. If you had 1,000 grams of sugar, how many ounces do you have? So again, start with 1,000 grams. You want to get rid of grams. You want to change it to ounces. It's best if we can have a 1 down here, because then we just have multiplication across the top. However, when I look on our chart on page 58, I don't see a conversion for 1 gram to ounces. So I'm going to have to see what I do have. I have a conversion for 1 ounce to 28.35 grams. So I can't avoid the division this time. Across the top, after we cancel those grams, we have 1,000 times 1, which is 1,000, over 1 times 28.35, and the units are ounces, so we have a division this time. So sometimes there's really no way to avoid it. This turns out to be 35.27 ounces when you do the division, and you guys can work on that long division. You can always use your calculator to check if you want to, but you really should be working on the multiplication division without the calculator. If the temperature was 37 degrees Celsius, what would the temperature be in Fahrenheit? And this is what I was saying before. When you're converting from between Celsius and Fahrenheit, you can't use the unit conversions with the fractions like we did before. You have to use the formulas given on the bottom of the chart there. So since we know Celsius and we want Fahrenheit, we're going to use the one that says Fahrenheit equals, because we want Fahrenheit, 9/5 times the Celsius plus 32. You can find that on the bottom of page 58. Of course, you need to put your Celsius amount in here for C, and that's going to be a 37, so we're going to substitute a 37 in there. And then following order of operations, we will multiply and then add. So that gives us 9/5 times 37 plus 32. 9/5 times 37 is 333 over 5 plus 32. You're probably going to want to take this, convert it to a decimal, because we express degrees in decimals. So 333 over 5 becomes 66.6 plus 32 makes 98.6 degrees, and we converted it to Fahrenheit.